I have earned a lot of money working on expensive plasma cutters that were broken by wet air generated in really cheap compressor systems. This is a pressure sensor that got rusty and stopped sensing pressure. I've also replaced a bunch of solenoids after large squirts of water got sucked out of the bottom of an air compressor or drip leg. There are many ways to dry air that are a lot cheaper than an hour's worth of the labor required to repair a plasma cutter. Your first line of defense against wet air is simply knowing how your current system is set up. You should follow all your air lines back to your compressor and make sure that you don't have any hidden drip legs that will accumulate water until the level is high enough to be sucked out by the Venturi effect. You may also find oilers where they aren't supposed to be, where they could introduce oil into electronics or lasers that aren't supposed to have oil. Unseen air leaks could also overwork your compressor and cause it to accumulate more water in more places than is necessary. Your second line of defense against wet air is just having drains. Small compressors are generally not built with drains because moisture usually gets sucked out of their small tanks with each use, and because they're generally used with oiled and factory finished devices like nailers that are very water resistant. Compressors larger than the bare minimum are usually built with a drain in the bottom, but the factory may install a plug or manual drain. I'm a big fan of electronic auto drains being plumbed into the bottom of compressor tanks. This avoids the possibility of people forgetting to drain the tank, and they're generally more reliable than float drains. Water can be encouraged to condense in your tank and above the drain by keeping your tank clean and cool. If you locate your compressor and tanks outside in some kind of louvered shed, that would promote airflow and reduce noise indoors. Black iron air lines also help keep your air cool due to their high thermal conductivity, and they can be more easily fitted with drip legs than flexible alternatives. You just have to remember to drain your drip legs. Filter dryers are cheap parts often installed at the end of a run of rigid airline, and usually have float drains or partially open valves on the bottom that allow a constant flow of air and water at a slow rate. An auto drain and filter dryer are usually sufficient to protect plasma cutters from the vast majority of their failures, and can both be purchased for under $100. Plasma cutters usually come with filter bowls, but they're often built into the case and aren't serviceable. They'll help, but if you run dirty or moist air, they'll eventually clog, accumulate water, and start doing more harm than good. Some are easy to clean if you take off the case, but others require you to cut parts off the case in order to clear a clog. Your air should be pretty clean before it gets to your plasma cutter, just in case your plasma cutter was designed by a dipshit. If you have more money than you know what to do with, or are running equipment that is more sensitive than a plasma cutter, you have a couple of expensive options. Desiccant dryers have a filter bowl containing an absorptive media that traps moisture as it passes through. They periodically need to be recharged, either by buying filter media or leaving your filter media in a rod oven for a couple of hours. Industrial desiccant dryers exist that use 2 cylinders full of desiccant, and a computer keeps one cylinder in the air circuit while it recharges the other one using exhaust air. Refrigerated dryers are usually the most expensive, and use a refrigerant circuit to cool down an enclosed loop of copper pipes. They come in cycling and non-cycling varieties. Cycling dryers run slower when air isn't being used and save a lot of energy, but are more expensive and often less reliable. Refrigerated systems can start at a couple of $100s, but I've seen systems at an aluminum foundry and a medical device manufacturer that probably cost tens of thousands. They run expensive, high-precision, and high-volume equipment on multiple shifts, and have some ISO certifications that might require dried air. They also have a lot of oversized pipes and accumulator tanks close to the point of use. Large facilities often need accumulator tanks, which can just be out-of-service compressors if you're cheap. Accumulators should also be kept cool and have drains. Tire shops are weird because they run the least water-sensitive equipment ever produced. They really require no drying. In fact, most of their equipment would benefit from an oiler, which is kind of the opposite of a dryer. But they could advertise dry air because dry air expands and contracts less with temperature, which is why a lot of performance tires are filled with nitrogen, which is dried cryogenically. Dried air might be more convenient than nitrogen, but buying nitrogen is pretty cheap, so most tire shops just stick to selling nitrogen versus dried air. Spending more money on drying your air will make your equipment last longer and operate slightly better, but the sweet spot in price really depends on your application. Everyone needs an auto drain, and if you're running a plasma cutter, you definitely need a filter dryer and probably an accumulator tank. Some YouTubers have DIY'd copper coils and swamp coolers in order to imitate the function of a refrigerated dryer on a budget, and have gotten some good results. But DIY options often cost more than a refrigerated dryer from Harbor Freight.